Hello friends and welcome to YouTube channel on Engineering Mathematics by Dr. Navneet. Friends, in this video lecture we are going to learn how to find the inverse Z transformation by binomial expansion. So before starting with the actual concept, so let me first define inverse Z transformation. So friends, the definition of inverse Z transformation is very simple. So this definition says that if we denote the Z transformation of sequence UK as Z UK, and if we denote this by f of z, then this uk is called inverse z transformation of f of z, and symbolically we can write this as uk is equal to inverse z transformation of f of z. So this is the simple definition of inverse z transformation. So friends, for finding the inverse z transformation, there are three important methods. So first method is that, so we can easily find this inverse Z transformation by binomial expansion. So this is the first method to find the inverse Z transformation. Then second method is partial fraction. So inverse Z transformation by partial fraction expansion. So this is the second important method for finding inverse Z transformation. And third method is direct division. So this is direct division, or some people may call this as long division. So these are the three important methods we are learning under the concept of inverse Z transformation. Again friends, we are covering two lectures based on this binomial expansion. So again we are conducting two lectures based on this partial fraction expansion, and we are conducting one lecture on direct division or long division. That means total we are conducting 5 lectures to understand the concept which is called as inverse Z transformation. So in this video lecture we are learning how to find the inverse Z transformation by binomial expansion. So we know that the meaning of expansion of a function in our previous semester. So according to concept expansion of function, so we know the binomial expansion of the term 1 upon 1 plus x, which is also written as 1 plus x raised to minus 1, which is written as 1 minus x plus x square minus x cube plus x raised to 4 minus x raised to 5, and so on. Again we also know that the expansion of 1 upon 1 minus x, which is 1 minus x raised to minus 1, which is also written as 1 plus x square plus x cube plus x raised to 4, and so on up to infinity. So friends, these are the two simple formula for the expansion of function. So here the power of this bracket is 1. So in today's lecture we are solving the example based on inverse Z transformation when the power of this term is 1. So in our next lecture we are learning how to solve the example based on binomial expansion of the type a plus b raised to n. So we are covering this topic in our next lecture. So based on these two standard results in today's lecture, we are solving the example based on the inverse Z transformation. So let's friend take the first example. So first example is, so question is, find the inverse Z transform of, suppose function is, so our given function is defined as f of z is equal to 1 upon, this is z minus a. So first condition is that mod of z is less than mod of a, and second condition is that mod of z is greater than mod of a. So now friends, this is the example we have to solve with the help of inverse Z transformation. So this is the given function 1 upon Z minus A, where mod of Z is less than mod of A and mod of Z is greater than mod of A. So now friends, before solving the actual example, let me first revise how we are solving the example based on the Z transformation definition. So while solving example, first step is that, so to find out the Z transformation of any sequence, we are writing the definition as uk z raised to minus k, its summation. So here summation k goes from minus infinity to plus infinity, but for our simplicity purpose we take here unilateral sequence. That means we take the value k from 0 to infinity. So then after writing this step, our next step is to expand this summation sign. So we can write this as u1 then z raised to minus 1 plus this is u0, this is u0 z raised to 0. So we can write this, then we can write this as u1 z raised to minus 1 plus this is u2 z raised to minus 2 and so on. Then we can get this as uk z raised to minus k and so on up to infinity. So friends, after expanding this sequence, we get either geometric progression, so geometric progression of the type 1 plus r square and so on. Then after getting this such type of geometric progression where the value of mod of r is less than 1, we write its geometric progression in terms of 1 upon 1 minus r, where the value of mod of r is less than 1. So friends, these are the 4 important steps for solving the example. Once again I will revise. First write down the definition. So in this definition, so the value of z raised to k is here. So coefficient of this z raised to minus k is uk, and the meaning of uk is inverse z transformation. So to find out the inverse z transformation means what? Find out the z raised to minus k coefficient, so which is denoted by uk. Now how to find this z raised to minus k coefficient? So we know that, so this coefficient is, so here which is given here, z raised to minus k coefficient uk here. So how to obtain this uk? So we can apply the geometric progression and so on. So this is the method of solving an example with the help of Z transformation. Now friends, to find out the inverse Z transformation means do exactly reverse thing. So that means first find out the value of mod of r less than 1. That means according to the given condition mod of z is less than mod of a. So first we have to write down this as mod of r less than 1. Then next step is that write down given function. That means this is the given function. So write down this given function in terms of 1 upon 1 minus r, or sometimes we may write this as 1 upon 1 plus r. Then use binomial expansion formula. So use this first and second formula so that we get such type of expansion. Then the coefficient of this z raised to minus k, coefficient of z raised to minus k is uk, and the meaning of uk is called as inverse z transformation. So let's apply the reverse process so that we can get the inverse Z transformation. So what is the first step? What is the first step, friends? So here mod of r is less than 1. So here if we try to solve the first example, then mod of z is less than mod of a. So if we try to convert this in terms of mod of r is less than 1, then we get this as z upon a is less than 1. So this is the value of r, where value of r is z upon a. So this is the value of r. Now friends, our aim is to write down the given example in terms of either 1 minus r or 1 plus r. So what is the given example? So here the value of given example is f of z is equal to 1 upon z minus a. So our aim is to write down this as 1 upon 1 minus r, so that we can apply this first or second result of binomial expansion. So to write this value, so take the help of this condition, mod of r is less than 1, so write down the value of r. So here value of r is z upon a. Now to get the value of r as z upon a, we can take the term 1 upon a common, then we get this as z upon a minus 1. So after taking this a common, we may write this in this form. So this is the alternative form. So if we take the term a common, then we get this as a z upon a minus 1. But we require this as 1 minus r. Our equation is in terms of 1 minus or 1 plus x. So to get 1 as the first term, we may write this as minus 1 upon a. Then this is 1 upon 1 minus z upon a. So that we get this equation either this form or this form. This is 1 upon 1 minus x. So this is 1 upon 1 minus x. So that we get such type of form. Now friends, we may write this as minus 1 upon a as it is. Then this is 1 minus z upon a raised to minus 1 after taking this term in the numerator. Now friends, please try to understand that this 1 upon a is constant. Now if we observe this term 1 minus z upon a raised to minus 1, then this term is of the form 1 upon 1 minus x, or we may write this as 1 minus x raised to minus 1. Then its expansion is 1 plus x square and so on. So here the value of x is z upon a. Now according to this formula, we may expand this term as minus 1 upon a as it is. Then according to this formula, we can write each expansion as 1 plus x means this is z upon a, plus z upon a its square, plus this is z upon a its cube, and so on. But friends, how long we have to continue this expansion? So friends, please try to understand that our aim is that after expanding this term, we get such type of geometric progression. So, and our aim is to find out the inverse Z transformation. To find out the inverse Z transformation means find out the value of sequence uk, and sequence uk is the coefficient of z raised to minus k. So expand this term up to z raised to kth power. So we can write this as, so next term is plus, so we can write this as z upon a raised to kth term. So friends, here purposefully we write this kth term because we are interested in the coefficient of z raised to minus k. So that coefficient of z raised to k minus k is uk, and which is the value of inverse Z transformation. So now to find out the inverse Z transformation of this term, that means find out the coefficient of z raised to minus k. But here this minus 1 upon a is multiplied to this bracket, so multiply this to the inner side so that we get this as minus, then this is 1 upon a plus this is 1 upon a square, then numerator we can write this as z, plus this is z square upon a cube, plus this is z cube upon a raised to 4. After multiplying this 1 upon a to the inner side, we can continue in this way. We get this as z raised to k upon a raised to k plus 1 and so on. So we get such type of expansion. That means we get such type of expansion. So friends, here our aim is to find out the coefficient of z raised to minus k. So here we get the value of z raised to k. So therefore coefficient of z raised to k equal to, so coefficient of z raised to k is this minus sign as it is, and then this is 1 upon a raised to k plus 1. So 1 upon k plus 1. So we can write this as minus, this is a raised to minus k minus 1. So this is a raised to minus k minus 1. That means we get the coefficient of z raised to k here, but after multiplying by minus sign to this term, we get the coefficient of z raised to minus k. So now here our next aim is to find out the value of condition on k. That means how long k goes. K goes from either 0 to infinity or minus infinity to plus infinity. So now friends, this is the kth term. In this kth term, so put the value of k in such a way that we get this first term. So here if we put k is equal to 0, so then what happen? If we put k is equal to 0, then z raised to 0 is 1. Then if k is equal to 0, then this is a raised to 1, which is available here. So that's why condition on k is that k is greater than or equal to 0. So meaning behind it is that, so we are finding the value of k where summation goes. That means here k is greater than 0 indicate that summation goes from 0 to infinity. So this is the meaning of k, and we are finding this k by putting particular value in this kth term so that we get the first term. So this is the first term, k is equal to 0, k is equal to 1, 2, 3, 4 up to infinity. That's why k is greater than or equal to 0. Now friends, here we get the value of z raised to k, but our aim is to find out the value of z raised to minus k coefficient. So therefore coefficient of z raised to minus k term is, so we can write this as a raised to, this is k minus 1, so this k is less than or equal to 0. So here we replace z by minus this k by minus k, so that here this minus k become plus k, and when we multiply any inequality by minus sign, then this middle sign will get changed. So this minus k indicates that k is less than or equal to 0. So this is the value of coefficient of z raised to minus k. So z raised to minus k, that means we get the value of sequence uk. So actually this is the value of coefficient. So this is the value of uk. So therefore we can write this as inverse z transformation of 1 upon z minus a, or we can write this as inverse z transformation of f of z, which is equal to, so value of sequence uk. So this inverse z transformation is uk. So according to this formula we can write this as minus a raised to k minus 1, where k is less than or equal to 0. So friends, this is the solution to the first condition. So now let's take the solution to the second condition. Now second condition. Now friends, here second condition is that mod of z. So this is mod of z is greater than a. So mod of z is greater than a. So according to the geometric progression concept, so first write down mod of r less than 1. So if we try to write down this condition, then we get this as z upon a is greater than 1. So this is greater than 1, but we require this as less than 1. So therefore we can take the reciprocal of this term. So we get this as a upon z is less than 1. So this is the value of mod of r less than 1. So this is the condition. Now next step is that write down given example in terms of 1 upon 1 minus r or 1 plus r. So here given example is f of z, which is 1 upon z minus a. So here friends, this is mod of r less than 1. So write down this as 1 minus r. So where the value of r is a upon z. So try to take the term z common from this term. So we get this as 1 upon, if we take the term z common, then we get this as 1 minus a upon z. So purposefully we take the here z term. So because we require equation in the form 1 upon 1 minus r, where the value of r is a upon z, and we get the value of a upon z from this term after taking z common. That's why we take z here common. So moreover we can write this as 1 upon z, then 1 minus a upon z raised to minus 1. So this 1 upon z as it is, we take this bracket term in the numerator, where power is minus 1. So friends, this term is of the type 1 minus x raised to minus 1, where the value of x is a upon z. So according to this formula, 1 plus x square and so on, we can expand this bracket as this 1 upon z as it is. So according to this formula, we can write this as 1 plus x, value of x is a by z plus x square, that means a upon z its square plus a upon z its cube plus and so on. Friends, our aim or our target is to get the value of z raised to minus k. So we can write general term of this term as a upon z raised to k plus and so on. So in this way we can expand this bracket according to this formula. But please try to understand that our main interest is the coefficient of z raised to minus k. Now friends, this 1 upon z is available here. So take this z to the inner side, then we get this as 1 upon z plus this is a upon z square plus this is a square upon z cube plus this is a cube upon z raised to 4 plus and so on. Now friends, here please try to understand that if we multiply this denominator by z, then this we get this as z raised to k plus 1, because this is z raised to k and this one, that means we get z raised to k plus 1. But our interest is to get the value of z raised to minus k. So this is z raised to k plus 1. So before that means previous value is z raised to k. So we can write this as a raised to k minus 1 divided by this is z raised to k, so that we get this as the kth value. So because our interest is to find out the value of z raised to minus k coefficient, here we get this as z raised to k plus 1 coefficient. So previous term is a raised to k minus 1 z raised to k, and we can continue this up to infinity. So after multiplying z to the inner side. Now friends, this equation is directly in our standard form because we are interested here coefficient of z raised to minus k. In previous example, we get z raised to k coefficient where we multiply by minus sign and got the value of z raised to minus k. So here we can directly get the coefficient of z raised to minus k. Now coefficient of z raised to minus k. So after taking this z raised to k in the numerator, we get this as z raised to minus k. So this coefficient is a raised to k minus 1. So this is the value of a raised to k minus 1. Now find the condition on k. That means how this k goes from for this summation. Now friends, for this kth term of z, so put the value of k in such a way that we get this as the first term. So if we put k is equal to 1, then we get this term. So k is equal to 2, this term, k is equal to 3, k is equal to 4, k is equal to k, and so on. That means condition on k is that k is greater than or equal to 1. So if we put k is equal to 1, we get this term, 2, 3, 4, and so on. So that means k goes from 1 to infinity. That is the meaning of this k is greater than or equal to 0. So therefore we can write inverse z transformation of f of z, which is written as inverse z transformation of f of z is equal to sequence uk, and which is also written as inverse z transformation of this f of z. The f of z is given by this term, which is z 1 upon z minus a. For this second condition, mod of z is greater than a, so this is the big condition, and for this condition, so value of this term is a raised to k minus 1, where k is greater than or equal to 1. So friends, in this way we can easily solve the example based on the inverse z transformation by binomial expansion. So now this is the first example. Let's take the second example. Now friends, second example is so example number second. So example second is find the inverse z transform of, suppose the value of f of z is z upon z minus a. So this is the given example where first condition on z is that mod of z is greater than mod of a, and second condition is that mod of z is less than mod of a. So this is the second condition. Now friends, our aim is to solve this example. Friends, whenever we solve any example, first concentrate on condition on z. So if we try to solve the first condition, then mod of z is greater than mod of a. Now to solve any example based on this inverse z transformation, first write down the value of mod of r less than 1. So if we try to write this, then we get this as this is z upon a greater than 1. So if we take the reciprocal, then we get this as a upon z is less than 1. So this indicates that the value of r is a by z. So write down the given example in terms of 1 upon 1 minus r. So we can write given example as f of z is equal to, this is z upon z minus a, which is equal to. Now friends, here the value of r is a by z. That means write down this example in terms of 1 upon 1 minus r or 1 plus r. So where r is a by z. Now to get the value of a by z from this denominator, so we can take the term z common, so that we get this as a by z. So now this is z as it is. So if we take the term z common from denominator, then this is 1 minus a by z. So we take this z common, so that we get this as a upon z as r term. So now friends, if we try to simplify this, then this z will get cancelled, and this is 1 minus a upon z raised to minus 1. So z term will get cancelled. So this z and this z. So if we take this in the numerator, then we get this term. Now friends, if we compare this example with this expansion, then value of x is a by z. So if we apply this formula and if we try to expand the given example, then we get this as 1 plus x, that means a upon z, plus this is a upon z its square, plus this is a upon z its cube, plus and so on. Our main interest is in the coefficient of z raised to minus k. So that means write down the coefficient of z raised to k. So we get this as a plus a upon z raised to k and so on up to infinity. Now friends, we can directly write the coefficient of z raised to minus k, that because here power of z is minus k, or for understanding purpose we may write this as 1 plus a z raised to minus 1 plus this is a square z raised to minus 2 plus this is a cube z raised to minus 3 and so on. So this is plus a raised to k z raised to minus k and so on. So for your better understanding purpose, we write this term in this way. So now friends, our aim is to find out the coefficient of z raised to minus k, which is sequence uk. Now here coefficient of z raised to minus k is a raised to k. So therefore we can write this as coefficient of z raised to minus k. So this coefficient is a raised to k. Now next aim is to find out the condition on k. So now to find the condition on k, so this is the kth term. So in this k term, put the value of k in such a way that we get the first term as 1. So how to get this first term as 1? We get this as k is equal to, if we put k is equal to 0, then we get this as a upon z raised to 0, that means 1. So that means k is equal to 0, then we get this term. So put k is equal to 1, we get this term, k is equal to 2, k is equal to 3 and so on. That means condition on k is that k is greater than or equal to 0. So therefore we can write inverse z transformation of f of z, which is also written as inverse z transformation of f of z, means this is z upon z minus a, where mod of z is greater than a and the value of this term is a raised to k for k is greater than or equal to 0. So this is the solution to the first condition, that mod of z is greater than a. Now take the solution for second condition, mod of b. Now friends, second condition b is that mod of z is less than a. Mod of z is less than a. So our aim is to write this as mod of r less than 1. If we try to convert this in terms of r less than 1, we get this as z upon a is less than 1, where the value of r is z upon a. Now friends, next aim is to write the given function in terms of 1 upon 1 minus r. So here given function is f of z is equal to, this is z upon z minus a. So this is the given function. So write down this function in terms of 1 upon 1 minus r or plus r, where the value of r is z upon a. So now write down this denominator in terms of z upon a. So to get this term, now take the term a common from denominator. So we get this as z upon a minus 1. So after taking a common, we get this as z upon a, so that we get this as the value of r. Now but here we required first term as 1, or we required here first term as 1. Now to get first term as 1, let's take the let's write down the first term as second and second term as first. For this we multiply this by minus sign, so we get this as minus z upon a, so in bracket we get this as 1 minus z upon a. Now if we try to simplify this, then we get this as minus z upon a as it is. Then if we take this in the numerator, then this is 1 minus z upon a raised to minus 1. So then according to this standard formula, value of x is z upon a. So we can write this as minus z upon a as it is. Then expand this according to the formula. So 1 plus x means z upon a plus x square, that means z upon a its square plus z upon a its cube and so on. We get this as z upon a raised to k plus and so on up to infinity. Our main interest is to get the value of z raised to minus k. So that's why write down the middle term as z raised to k. Now friends, here minus z upon a is multiplied to this bracket. So now take this term in the inner side of bracket. So this minus sign as it is. So this is z upon a, then this is z square upon a square. After multiplying these to the inner side, we write the power of numerator and denominator separately because we are interested in the power of z raised to k coefficient. Now, so this become plus, this is z square, then this is z square into z, which is z cube, upon this is a cube plus and so on. So now friends, if we multiply this z upon a to this term, then we get this as z raised to k plus 1 upon a raised to k plus 1 and so on. So we get such type of term. But friends, our interest is to get the value of z raised to minus k coefficient. So we may adjust the minus or plus sign, but here power of z is z raised to k plus 1 and our interest is to get the value of z raised to minus k. So previous to this term is z raised to k upon this is a raised to k. So and so on. So in this way we get the previous term to this term. So now here we get this as z raised to k. After multiplying by minus 1 we get this as z raised to minus k. Now friends, according to this expansion, therefore coefficient of z raised to k. So here power of z is positive, that's why we can write this as z raised to k. Afterwards we will multiply this to minus. So z raised to k is equal to, this is minus sign, then this is 1 upon a raised to k. Moreover, we can write this as minus a raised to minus k. Now next thing is that, so write the condition on k. That means this is the kth value of given sequence. Now in this sequence put the value of k in such a way that we get this as the first term. Now to get this as the first term, if we put k is equal to 1, then we get this term. That means k start from 1 to infinity. K is equal to 1, we get this term. K is equal to 2, k is equal to 3, this is k is equal to k, and so on up to infinity. That's why condition on k is that k is greater than or equal to 1. Now friends, we are interested in the coefficient of z raised to minus k. Now here we get the coefficient of z raised to k. So therefore coefficient of z raised to minus k is equal to, that means replace k by minus k, we get this as minus a raised to k, minus 1 has become plus k, then this k is greater than or equal to 1. Or we may write this condition as k is strictly greater than 0, or we may write this as k is greater than or equal to 1, or k is strictly greater than 0. So this is the alternative way to represent the value of k. So therefore we can write inverse z transformation of f of z, which is same as inverse z transformation of value of f of z is, this is z upon z minus a, and its value is, according to this formula, that inverse z transformation of f of z is sequence uk. So that's why we can write the sequence uk, and which is minus a raised to k, where k is greater than or equal to 1, or we may write this as k is strictly greater than 0. So friends, in this way we solve the second example. Now let's take the third example. Now friends, let's take the third example. So third example is find inverse z transformation of z upon z minus 5 if first condition is that mod of z greater than 5 and second condition is that mod of z less than 5. So we will solve, or we will find the inverse z transformation according to the first condition. So if we try to solve example with the first condition is that mod of z greater than 5. Now friends, to write this as mod of r less than 1, we can easily write this as z upon 5 is greater than 1 after taking this 5 to the left side. So but we require here condition that mod of r less than 1. According to this we can take the reciprocal, then we get this as 5 upon z is less than 1, so that we get the value of mod of r. So here r value is 5 upon z. Now write down the given example. So we can denote this example by f of z, and value of f of z is z upon, this is z minus 5. Now write down this example in terms of 1 plus x or 1 minus x, or we can write this as sum of geometric progression as 1 upon 1 minus r, where the value of r is 5 by z. That means try to write this denominator in terms of 5 by z. So now to get this as 5 by z, we have to take the term z common from denominator. So we get this as 1 minus, this is 5 by z. So this z will get cancelled. So we take the term here z common because we get here as 5 by z according to the value of r. That means we have to take z common. We may write this as 1 minus, this is 5 by z raised to minus 1. If we compare this with the second condition, then value of x is 5 by z. We can easily write its expansion as 1 plus this is 5 by z plus this is 5 by z its square plus this is 5 by z its cube and so on. Our main interest is to get the value of z raised to minus k. That means kth term is 5 by z raised to k and so on up to infinity. So in this way we directly get the value of z raised to minus k coefficient, or moreover if we try to simplify this, then we get this as 1 plus 5 z raised to minus 1 plus this is 5 square z raised to minus 2, then 5 cube z raised to minus 3 and so on. We can write this as 5 raised to k z raised to minus k and so on. So our interest is to get the value of coefficient of z raised to minus k. So therefore coefficient of z raised to minus k. So this coefficient is 5 raised to k. Now in this kth term, put the value of k in such a way that we get this as the first term. So now to get this term, we get this as k is greater than or equal to 0. That means for k is equal to 0, either this equation or in this equation, put the value of k in such a way that we get this as the first term. So we get the value of 1 after putting k is equal to 0. This is the term after putting k is equal to 1, 2, 3, 4, so on up to infinity. That's why this k is greater than or equal to 0. So therefore here we get the value of z raised to minus k, and the z raised to minus k means uk, and this uk indicate the inverse z transformation. So therefore inverse z transformation of f of z, which is same as that of inverse z transformation of z upon z minus 5, and its value is 5 raised to k for k is greater than or equal to 0, and this is happen when mod of z greater than 5. So now this is the first condition. Now let's try to solve equation for second condition. Now friends, second condition is B condition, mod of z is less than 5. So this indicates that z upon 5 is less than 1. That means value of r is z upon 5. So that's why we can write the given example as f of z is equal to, this is z upon z minus 5, which is equal to. So our aim is to write down this as z upon 5. That means here we get this as z minus 5. So now to get z upon 5 as one of the term in the denominator, so take the term 5 common. So we can write this as z upon, this is 5, then this is z upon 5 minus 1. So we can write the value of r according to the mod of r less than 1, where r is z upon 5. That's why we take the term 5 common. So now here we require either 1 minus x or 1 plus x. Here we get this as x minus 1, where x is z by 5. We can rewrite this as minus z upon 5, then this is 1 minus z by 5. Minus z by 5, 1 minus z by 5. So moreover we can rewrite this as minus z upon 5, then 1 minus z upon 5 raised to minus 1. Again we get same equation, same expansion, apply this expansion. We get this expansion as z upon 5, then this is 1 plus z upon 5 plus z upon 5 its square. We can continue this up to z upon 5 raised to k plus and so on up to infinity. So now our main interest is to find out the value of coefficient of z raised to minus k. That's why we write this as kth term. So here plus sign. Now take this z upon 5 to the inner side, so that we get this as minus as it is. Then 1 into z upon 5 means this is z upon 5 plus this is z square upon 5 square plus this is z cube upon 5 cube and so on. If we multiply these to this side, then we get this as plus z raised to k plus 1, because this is z raised to k and this is z, that means z raised to k plus 1 upon we get this as 5 raised to k plus 1 and so on up to infinity. But friends, our interest is to get the value of z raised to minus k coefficient. Now here we get coefficient as z raised to k plus 1. We required previous to that coefficient. That's why previous to this term is z raised to k upon 5 raised to k. So that we get the value of z raised to k coefficient. After multiplying k by minus 1, we get this as z raised to minus 1 coefficient. So therefore we can write the coefficient of z raised to k is equal to, so this is minus sign and its coefficient is 1 upon 5 raised to k. 1 upon 5 raised to k. Moreover, we can write this as minus as it is, then 5 raised to minus k. Now next aim is to find out the condition on k. So in this kth term, put the value of k in such a way that we get this as the first term. And it is possible when we put k is equal to 1, we get this term. K is equal to 2, k is equal to 3 and so on up to infinity. That means condition on k is that k is greater than or equal to 1. Or moreover, we can write this as k is strictly greater than 0. So either we write this as greater than 1, equal to 1 or strictly greater than 0. But here we get, friends, the coefficient of z raised to k. But our aim is to get the value of coefficient of z raised to minus k. So therefore we can write this as coefficient of z raised to minus k is equal to, this is minus, that means replace k by minus k, we get this as minus as it is 5 raised to k, then this is k is less than or equal to 1. After multiplying by minus sign, this inequality will get changed, or we may write this as k strictly less than 0. So therefore we can write inverse z transformation of z upon, this is z minus 5 and its value is according to this formula that inverse Laplace transformation is sequence uk, and value of uk means coefficient of z raised to minus k, and this value is minus 5 raised to k for k is less than or equal to 1, or we may write this as k is strictly less than 0. So friends, here we solve 3 important example. Now let's take the some example for your practice purpose. Now friends, after solving 3 important example, time is to test your knowledge. So for testing your knowledge purpose or for your practice purpose, total 6 examples are given. So first example is f of z is equal to 1 upon z minus 1, where mod of z is greater than 1 and mod of z is less than 1. Answer is that we get inverse z transformation as sequence uk is equal to 1 for k greater than 1, and the value for this second condition is that sequence uk is equal to minus 1 for k is less than 0. So now friends, this is the second example where the value of f of z is z upon z minus 1. So this is same as that of our example number 2, only we put the value of a as 1. So this is the first condition, its solution, second condition, then its solution. Then third example is same as that of our example number 1, where we put the value of a is equal to 3. Now first condition is that mod of z less than 3. This is the answer related to this inverse z transformation, and this is the value of mod of z greater than 3, and this is the solution related to inverse z transformation of this third example. Now fourth example. Whatever lecture in this lecture, whatever example we solve, in that example everywhere we use the expansion formula 1 upon 1 minus x. Now this is the example number 4, where denominator is z plus a, where we are using this first expansion. So this is the example where we are going to use the first expansion. Now this is the first condition, and this is the answer related to this condition. Now fifth example, f of z is equal to 1 upon z minus 2, mod of z greater than 2, this is the answer, mod of z less than 2, this is the answer. Now sixth question is f of z is equal to 2z upon z minus a, mod of z greater than a, answer, mod of z less than a, and this is the answer related to this second condition. So friends, try to solve all these 6 examples for your practice purpose. So friends, I hope you people like this video lecture. So thanks for watching this video lecture. Thanks to one and all. Thank you.